What are with construction of these projects and maintenance and long-term operational maintenance, what are some of the civil concerns that you need to deal with or be factoring in? Obviously, you talk about Houston. Houston, you don't think is, being flooded all the time, but we have hurricanes now and 500-year floods every 5 years, it seems. Um, what are some considerations there that you guys see?
Well, from a civil perspective, a battery is a fairly simple prospect compared to, say, let's say wind turbines, where you've got these like massive structures. At its heart, a battery is a very heavy box, which sits usually on a concrete pad. So it's fairly simple, but that's not to say it's totally foolproof. There are still a lot of concerns you have to think of from a civil perspective. So the first would be geotech, meaning geotechnical engineering. As part of the process, you're coming in, doing boreholes, trying to figure out what the character of that subsurface is. Do you have real sandy soils or clayey soils or whatever the case may be? And that's going to determine what type of foundation you'll need for these battery containers and also the containers for the inverters or the substation, all the other components that go into the system. The two big classes that we see of foundations are either pile driven foundations, meaning steel piles that are driven into the ground, and then you'll set your containers on top of those, or concrete foundations, meaning just a concrete pad that's poured. In either case, most common is you'll have a stub up, meaning conduits are buried underground so that they can run the cabling and the conductors right into the containers themselves. So those are the two most common. We are starting to see some providers, some energy storage products that would allow for them to be set on a compacted foundation. So the civil conditions would have to be just right, or the soil conditions would have to be just right. But clearly, like if you're able to compact the land and then set the container down, and in some cases not even use conduits, but to use above ground raceways or ways to get your cables around between the containers. Obviously, that can save a lot, both in cost and in timeline for construction of the projects. But it's not every jurisdiction that allows that, and it's not every product that allows for it either. So those are the biggest concerns when it comes to the geotechnical. But also, as you mentioned, flooding is a big concern. So typically, for each of these parcels, you'll have to do a study to look at, okay, what's the most common rainfall we'll experience. I was working on a project in Taiwan where they have typhoons, so where the hurricanes that come through, they can dump, several inches of rain within a course of a few minutes. And so then you've got to study, okay, if that were to happen, how's the water going to get off the site? Are we going to have to grade it in a certain way or have retention ponds? All those are parts of the concern that influence whether a parcel will be a good fit for energy storage, or if you have to do a certain amount of work to get it to where it's in good shape to be a battery project.
How do these, and I think about this, we just obviously just had, Hurricane Beryl here in Houston, and the substation next to my house had a foot of water, standing over it. How do these projects withhold, standing water if they get water penetration? Is that a done, battery storage project? Do you have to completely rebuild, or are you only replacing certain battery components within that container? How's the if the worst happens on your project, you know, mother nature wise, how does that come into play?
So the first avenue would be prevent that from happening. So that involves picking the right parcel, and then picking the right foundation system. So for example, those pile-driven systems I talk about that sometimes can get your containers a couple feet above grade. Which if you're 5 feet of water, it's not going to make a difference. But if you have a foot of water, that can maybe make the difference on that site between your containers being submerged or not. The vast majority of the products in the marketplace have an IP rating, meaning that's ingress protection, meaning they have certain seals and whatnot. If you're in, say, a marine area where you have salty air, it may have to be a higher level than if you're not. They generally are not designed ever to have standing water, and if you were to ever have that condition, usually the site, first of all, would power down. One thing about that's unique to batteries is that on the cell or the module level, you can disconnect the individual components of a battery, but ultimately you've got a lot of energy stored there with a big positive and a negative terminal. And if you ever to have water get in there, that of course could be a huge fire risk or a short risk. And you can provide fusing and other protective devices. But if you were to have that happen, I think I haven't worked on a project directly that's had that problem, but I've heard of some that had water coming in. Most cases it was from bad rainstorm where there wasn't that proper sealing, meaning that you didn't, somehow water was getting in, and in that case, you really have to send inspectors in to kind of test either module by module or rack by rack to see what components have been affected. But it's simply going to take that system offline for a good amount of time, and all that's time that the system's not using and not earning its revenue. It gets into insurance, which is a big question of can you insure both the product itself and the project as a whole against different types of natural disasters.